Okay. So as I said to Sydney, it's not a new idea. What's new is it's a problem you've already solved before, but now you have to solve it without a calculator. The area of the region in the first quadrant, when you don't have a calculator, drawing pictures is helpful. So I've got first quadrant would mean I'm only concerned with this space. Quadrants are numbered 1, 2, 3, 4. You need me to repeat that? Yeah, don't ask me why things in math are sometimes random, but it's counterclockwise, like the unit circle. 1, 2, 3, 4. Okay, at this point you have to decide whether you want to use method A or method B. Okay, my method A is what I would call kind of the practical method. It's not perfect. Like there's about a 1% chance they may come up with something that's clever enough to make my method not quite work. Method B, though, requires you to go back in your memory and remember a lot of things you studied in previous years. And I find for most people that's a little difficult, so I prefer method A. So here's my method A, which no review is required. We're looking for the area in this region that is enclosed by these two graphs. Okay, so here's my method A. I have two graphs, somehow they enclose a region. That means somehow they intersect with each other. So I need to figure out how they intersect. So this part you do have to remember from previous classes. To find how they intersect, we set the two equations equal. So I write that down. But what I'm not worried about is I'm not taking the time to say graph those two equations, because that would require remembering quite a bit of things I learned in previous classes, and I don't find it productive. I think it's easier to don't worry about it, just let's find where they intersect. It'll be good enough. So, questions? Okay. Next thing you do have to memorize, and that is you're not going to solve an equation like this that has a cubic and an x by trying to get x alone. So we use the other method, which is we factor. So we want to get everything together on one side and then factor. So I make sure you're using the equal sign properly here. So there's a 0, and then I'll have x cubed plus 8 minus x minus 8. So I group everything on one side so that the equation equals 0. That's a memorized step. You just have to be able to look at this equation and say, no, I'm not going to solve for x. I instead want to get everything together. Okay. Well, these add to make 0. So now I have this. And I want to factor. So I can factor out an x. We want to talk more about that so far. It's a really good example of a problem where you don't want to be on autopilot. You want to be thinking as you work. But I say this all the time. Your future employer, even if you work for yourself, doesn't want someone who can't think. Okay? Just learn to kind of think as you work. Don't just do the work. This is a difference of squares. So that factors. We want to talk about that. Okay, now we encounter what's known as the zero property of multiplication, but the name doesn't matter. What's important is recognizing that you have in front of you three factors. There's only one possible way that three things multiply to get 0. One of them has to be 0. Hear the crowd rumbling? So one of them has to be 0. Okay. So please don't use the trick of like flipping the sign. That can cause mistakes. Just remember, when you solve an equation, you're trying to find the value of x, which makes the equation true. So here, if x equals 0, this would be -1, this would be +1, but who cares? 0 times whatever will be 0. So one solution is x equals 0. Now you can't lose track of what that means. So raise your hand and tell me, what does it mean when I write x equals 0 here? Like, what is the whole purpose of all this? Like, what have I now discovered? Hands, come on. More people. Talk to each other if you need to. What have I discovered? What did all this work tell me? What was the point of all the work? Hands, come on. Sophie?
That the two graphs are going to intersect at x equals 0.
How many knew it? Point, 2 for Sophie. Where else do the two graphs intersect? Hands, come on. Where else do the two graphs intersect? Luke?
At 1.
And?
And -1.
How many knew it? Point, 2 for Luke. Here's again where you got to make sure you're thinking as you're doing the work. One of those intersections does not concern me. Which one and why? Hands, come on. Which intersection do I not care about and why, Lauren?
-1 because it's on the
How many knew it? 2 points, 3 for Lauren. Question? Okay, so here's how I solved the problem without having to remember how things are graphed. I know I'm in the first quadrant. I know there is an intersection at x equal 0. So I make some assumptions now. There is a slight chance that my assumptions could cause trouble, but it's really small. I've actually never found my method to fail on an AP test question. So here's one curve, graphed with great accuracy. Sarcasm is not my strong point. Here's the other curve, graphed with equally elegant accuracy. You'll notice that all my graphs look the same, because it's a lot easier to just graph the same thing than have to remember how things are actually graphed. So, sarcasm again, not my strength. Okay. So there's x equals 0, there's x equal 1. Would anyone like more discussion as how to graph areas in this class? That works for every problem I've ever seen on the AP test. Find the intersections, just pretend the graph looks like that. Question? Okay, to find the area, the next thing I need is I need to know which graph is on top and which graph is below. So I use a really simple method. I go to the middle. Here the x-coordinate would be 1/2. And I check the y-coordinate for both curves at x equal 1/2. So I write down y of 1/2 is 1/2 cubed plus 8. 1/2 cubed is 1/8. So that's one y-coordinate, 8 and an 8. Sounds like we're measuring wood. Tape measures are laid out. 8, 1, 8. Now I check the other curve. That'd be 1/2 plus 8, hence longer or higher. So now I know the curve on top is y equals x plus 8. Questions? You want me to go through anything again? Please, Mary.
If this was like a written part of the test, would you want us to change like the y's to like f of x and g of x, so like it's not they're both not y's?
Oh, gotcha. I think you're okay either way, actually. That's a really good question. I'm going to pay a ticket for that one. So if you wrote down, f of x equals this, g of x equals this, that would be a little more clear. I do think the grader's okay with this organization, as long as you're nice and neat. It is a little confusing, but equally confusing because they gave you two equations that both say y. So, good question. Either way. We lost the pencil. Anybody else want to talk more about what we've done so far? Please.
Wait, so how do you know that the top one was white?
No worries. I want you to see it for yourself because then the memory is better. So remember this. You don't see a curve here, you see lots of dots. And every dot has an x and a y coordinate. How do I find any x, y coordinate?
You have an equation.
Plug it in, right? So what I did is I said, this is x equals 0. This is x equal 1. So I picked a really easy value in between, a half. And I said, if I plug that half into this equation, it'll tell me the x and the y coordinate. So I know that the curve, so this is the equation y equals x plus 8. This equation has a point at an x coordinate of 1/2 and a y coordinate of 8.5. Because I figured that out using the equation x plus 8. You good now?
Yeah.
Want me to keep going? Okay. 2 points. Good work. Anyone else? Please.
So when it's not just 0 and 1 for the intersection, and you need to find the middle point, do you go directly in the middle, or do you just choose an easy value in between?
Really good question. I just pick the easiest value that is in between.
Okay.
So my first pick is 0, if I can. But 0 was the intersection, not something in between. My second pick is 1, if I can, because that's the easiest math, right? After that, I just think about, what would be an easy number. Good question. Anybody else? Cool. Last thing, memorize fact. To find the area of a region, I simply integrate. I'm going to copy this because I'm running out of room. To find the area of a region, I simply integrate the top function minus the bottom function, just like you did with your calculator. So, clear all this off. Integrate from 0 to 1, top function, x plus 8, subtract the bottom function. Okay, I deliberately made 2 mistakes. If you can you can talk. If you can raise your hand and tell me the 2 mistakes, I'll pay you points. There are 2 errors in what I wrote. Talk and raise your hand. What are the errors? Hands up. Show me. Come on. Sarah. Pause there for a second. How many knew that? 2 points, 3 for Sarah. More points. Look up. Why? Like, why are these essential? What's the reason? Kennedy?
Because the entire thing needs to be connected, so what's that, the line?
The integral?
The integral has to be connected to the x, right, by multiplication. And unless you put parentheses there, it's just an addition problem.
That's really, everybody look, that's really well said. It's very well said. We talked from the very beginning that when you do an integral, all you're really doing is multiplying over and over again. So these two multiply together. This is the height of a very narrow rectangle that fits in the region. This is the width of the rectangle. So yeah, we have to show that those two things are multiplying. It's really well said. How many knew it? 0.2 for Kennedy. There's one more mistake. There's one other error. Rachel.
You need parentheses around the x cubed plus 8.
When I say subtract, I must subtract that as a whole, so I have to have the minus. How many knew? 0.2 per inch. Okay. Question? Please. Yes. So once I do that, then I say, oh, wait a minute. If I distribute the negative, it cleans up really fast. Again, think as you go. Don't get on autopilot. Question? Super happy. The AP test, we're getting very close to starting to practice the actual AP test. And the key on the AP test is you cannot be on autopilot. Every time you're on autopilot, they'll find a way to trick you. So just think on every step. You deliver it, you don't have to rush. The AP test is not a race. It's not like the ACT. So I need to find the antiderivative, because now we're using the fundamental theorem. Like this, look here. Think of it as we are integrating f prime. And the fundamental theorem says, since you can't really integrate f prime because you don't use a calculator, don't. Instead, go find the antiderivative, which would be called f, and plug in the numbers. That's the fundamental theorem. So this becomes this. Questions?
This might be a dumb question, but why are we using that? Like
This one here?
Yeah.
You can think of either one. Stay with me. So Calvin knows answer. If you don't, we'll get somebody to help. I'll pay a full ticket. Calvin gets the first shot at it. Oh no, it's good. It's good. It's not bad to have a shot at a ticket. So. Here's $20. You want a chance? Like, sure. Like, really, like, you don't get it, well, who cares? Look, no one talk. Okay, say to the class, this one's easy, we'll start here. In this equation, tell me, Calvin, how f prime is related to f.
It's the derivative.
So just say a complete sentence.
F prime is the derivative of L.
Perfect. Now say it the other way around.
F is the antiderivative of F prime.
Make sense?
Yeah.
Perfect. So over here, notice the symbols are different, but the meaning does not change because it's still the fundamental theorem of calculus. So tell the class how small f is related to capital F.
It's the small f of F prime walls.
It's not f prime, but it's the same relationship. So just say it. You got it.
So small f is the derivative of big F.
And the other way around.
And big F is the antiderivative of small f.
Perfect. Hence the $20. Wish I had $20. You know, I would go broke if I did that. So look up. Come on. Okay, listen. Okay, I may have given this example in this class. I may have not. No one talk. Let's ask, and we'll have you tell me. So I want you to vote. This means yes. This means no. Have you ever had a math class, this one or a previous one, where the teacher was trying to explain some sort of concept and you kind of just gave up and said, I don't understand anything that's happening, but I'm pretty sure I can memorize how to move the pieces. And if I just know how to move the pieces and he or she gives me a problem that's identical, I just move the pieces the same way and I will get the answer. How many have done this in a class? I'm voting for myself, so you can notice that I too am guilty of this sin. Okay, give yourself 2 points for voting. Look up. Look at me. Look at me. Okay, that's a really bad habit. Okay? Look, on the AP test that will not work. They always make the problems enough different that if you take that approach, you will mess up. You'll get the wrong answer. Look up, come on. It reminds me of what my granddaughter said once. She was about 3 years old and she got really excited. She's like, we get to play a game. We get to roll dice and move things. Like, she has no idea what's happening. She's like so excited to roll dice and move stuff. Okay? Look, don't do math that way. Don't just roll the dice and move stuff. Use the equal sign. So here's Calvin's question. Why am I using this to answer this question? Well, I have an integral right here. One option, pick up my calculator, type it in. But this is the non-calculator section. So instead, I use the equal sign. Equal means this is the same as this. So instead of finding the integral, I'm not going to. I'm going to find the antiderivative and plug into that antiderivative the limits. Because this equation says the answers will be the same. Whichever one I do, it doesn't matter. So I could pick up my calculator and do this, I'll get an answer. But instead I can find the antiderivative and plug in the limits, I'll get the same answer. I don't know if that answers your question.
No, it doesn't.
Okay. Anybody else? Good, Ashley? So now just finish the problem. So every time you replace an x, make sure you put parentheses. Otherwise, when negatives become involved, you'll often make a mistake. If this is the FRQ section, I'm about to stop working and get full credit. As soon as I put a minus there, I've got to remember that I need a big parenthesis because the negative will apply to many things that follow. So put a parenthesis. This case, it's not really going to matter much because 0, but on the written section of a test, I can stop right there and I will get full credit. So you definitely want to stop on the written section. Multiple choice, I have to keep going, so this becomes 1/2, subtract 1/4, which is 1/4. Can somebody verify that I have not made a mistake and that is indeed the correct answer? Thank you. Question? Do you want me to go through any of it again? Awesome.